Hey everybody, this is Larry. This is me going Q4 of the weekly contest 397. Find the minimum cost array permutation. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. This one, I'm going to start by, so I got the right solution. So I'm going to start by doing the naive dynamic programming solution, right? And not going to lie, I discovered this after the contest that apparently this works in C++ with minor optimizations, but not in Python, or I don't know, maybe other languages, but definitely not Python. So once again, Leetcode shows that Python is sad. I don't know that they intended it this way per se, but I feel like, yeah, it's just very hard to debug knowing what optimizations you need and whether those optimizations would be enough. But that said, there is a cooler way of doing it, which I will go over. But yeah, so this is the naive dynamic programming solution. To be honest, this is a 7-pointer, right? I'm not going to go over all the basics of dynamic programming in this video. Just to be honest, just to be frank, this is like, if there's a basic dynamic programming, this is maybe a step or two higher. Maybe not that much higher, but still, there are easier problems to practice dynamic programming. There are easier problems to do bit mask dynamic programming. And these are the things that you need for this problem. So if you're not strong enough for that, work on bit mask dynamic programming problems and then come back to this video or come back to this problem and try again. But this is basically what I had, and you should be able to do this part. With this code does not submit, by the way, or it times out. But I just want to go over this one first. And basically the idea here is just we want to brute force bit mask dynamic programming. And very quickly, the reason is because of this, and it's 14. So then that means that we can represent whether a number is used 14, because they're 2 to the 14. So yeah. The 2 to the 14 possibilities for each numbered or each index or whatever, or permutation, if you want to call it that, is used or not, right? So that gives a hint here. And yeah, and the thing is, if you look at this formula, which I'll copy paste here, so I use the assets. If you look at this formula, what do you notice, right? That means that if you want to separate this out, if you want to do one chunk of this at a time, you're going to need at least one thing, which is that if you're on, let me rewrite this as, perm I minus nums of perm I plus 1, right? Something like this. Roughly speaking, I mean, I know there's 0 case as well, but yeah. But because you have this, that means that you can do it one at a time, and that means that you need to know the previous number, which is pretty straightforward, or the current number. You need one of the numbers, right? So that you know the previous thing. So that means that we need an added dimension, which is the last digit, which is what I have here. Right, so I have 2 to the 14 bit mask, and then I have 14 elements for the last element, or last index, if you want to call it that. And then one more is that if you look at this formula, we need to know the first number, right? If you need to know the first number, then that means that there's going to be 14 first number, right? First number. And you have to kind of pass it out, because then now this changes the result. So yeah, so that's basically the idea. The idea here is going to be starting here, which is that we brute force the starting index, which is I, and then we calculate it with its best. We start from here. There is path construction in this, which is not hard, but it's not easy. So we'll go over that in a sec. But yeah, and here mask is equal to bit mask, which means the ith binary digit of the bit mask is 1 if num sub I is used, right? That's basically the idea. Or I think technically I is used. Yeah, one of these. And start is just the first what do they call it? Perm sub okay. Yeah, so if yeah, actually I is uses make. But first perm sub 0, right? I guess they're all perm sub 0. And then last is equal to perm of I minus 1, I guess, right? So that's basically the states that we have. And here we go if bitmask is full, which means that if we used all the digits, then we just calculate the last digit minus num sub start. And of course, this is foretold in this formula, right? The last digit or the last permutation index minus the first number, right? So that's why we have it like this, right? Absolute value of. Otherwise, we do a brute force to minimize this function, which is from best. We set it to infinity. We brute force trying the next number. You know, if it's unused, that's all this is saying. I mean, bitmask may look confusing, but this is all it's saying. If this ith digit is not used, then we do this way. We do a recursion. We set this bit to true so that we set ith number to used. We keep the start because we don't change the start. And then the next last digit is going to be I. And then we add the cost. And this cost is, of course, one of these costs, right? That's how that works. And yeah, and then if R is less than best, that means if this is a better answer, we update the best, which we return. But we also set the previous. Previous is actually one thing because I always, in the past, I do path reconstruction in backwards. Sometimes I do it forwards. In this case, it's forward. So this is actually like, basically this is just keeping track of the next index, meaning that if we go to the mask, start and last, like if these are the inputs, this is telling us what the next, or like if they already did the for loop, the next one should be I. That's what this is saying, according to this, right? Yeah. And that's pretty much it. This is, like I said, this part is pretty straightforward if you have a strong understanding of bitmask dynamic programming. And now this is path reconstruction, right? So let me actually also write on the top here, you need to know bitmask DP and path reconstruction. And path reconstruction is actually pretty straightforward. Here we do a for loop. We get the result with the best start. This is actually not supposed to be equal. We get the best start, right? And keeping in mind that for this problem, we also want to get the lexicographically smallest of them, right? So that means that if there's a tiebreaker, we always want the smaller number. So we only update it if best is less than R, right? Okay. Yeah. And then this is just path reconstruction, right? We create the inputs that we care most about. So this is just, you know, if best start is equal to the best I here, then we just record this. And then now we start at, you know, the previous thing, right? We set that as the first element. And then we just kind of traverse because we know that if we are currently at current mask, best start current, then we just retrace the path, hence path reconstruction, reconstructing the path by keeping track of the indexes that we cared about in the last place. And then we update the masks to change to that state, and we update current, and that's pretty much it. So yeah, so what's the complexity here, right? So as we said, so the complexity here, mask is going to be 2 to the 14. Start is 14, last is 14, right? And that's the number of all possible inputs. So time complexity is equal to total inputs times time per input, right? The units match is time per input, like this, if you want to think about it that way. And total inputs is going to be equal to, I mean, let me also rewrite it in a O of big O way. So this is O of 2 to the n, this is O of n, and this is O of n, right? Total number of inputs is going to be O of n squared times 2 to the n, right? Which is, let me pull out my calculator, 14 times 14 times 2 to the 14, which is, okay, I copy and paste, so like 3 million, right? But each input takes O of n times, which is 14 times, which is 14 times this thing, which is me plugging the code. So this is going to be too much in Python. Apparently in C++, if you do some optimization, it is just fast enough, and some of the top people did it, which makes me a little bit sad because I really like this problem, to be honest. I really like the observation that you have to make, which it took me a long time. I took almost an hour on this problem, and the wrong answer, I actually did try to submit this in C++, and I couldn't get it to work. I don't know. But yeah, so basically this is too slow. That's what I'm saying. So what did we do? So I did this in about like 10 minutes, and then I just sat around and did nothing for I don't know, another half an hour, say. And I was just trying to think about this. And to be honest, and you could watch this during the recording, the live recording, and I just couldn't figure it out. But I think one thing that I did notice is, and this is just by me putting in a lot of cases, is that the first number is always 0, right? If you could think about it this way, the best start is always going to be 0. Why is that? And this is almost like honestly, this is a proof, and it's a very easy proof, but the reason why I did not, and I just couldn't get it during the contest, but as soon as I saw the proof, I was like, oh yeah, of course. But it was just so, and I really did dig it as a nerd, to be honest. I really dig this solution, which is why I feel a little bit cheapened that the n cube times 2 to the n solution works in C++. But yeah, but the key idea is that best start is always 0. Why is that, right? What is the proof here? So the proof is that if you look at this function again, well, what does this mean, right? Well, if you want to, the proof is actually pretty easy, because now let's say you have this function. What do you want to do? So it's very easy to move things around, right? So let's say we move this around to this thing, right? Well, then what do you have here? Well, this is just the same function as this, except for now you replace 0 with n-1, right? And 1 with 0. And that means, what does this mean exactly, right? If you kind of look at this, if you want to change, and this is the same sum, right? I just kind of move things around. This is the same sum. So here, the permutation array is going to be perm0, perm1, perm2, perm3, ... perm n-1, right? And here, if you write it out, the permutation is just perm n-1, perm 0, perm 1, perm 2, ... right? And then, I don't know, perm n-2, I guess, right? So what does that mean to us? That means that given this solution, we can also get a solution that is shifted 1 unit, right? And of course, it's not and this is a very easy proof, I think, right? And now that you prove that you can move 1 space to the right, what does that mean? That means that you could also move 1 more space to the right, and you have the same answer, right? It'll give you the same score, right? So that means that this score is, of course, the same formula as if you did the same thing, but perm n/2 or n-2, right? ... So then now, how does this help us? Well, the thing is, you know that one of these numbers have to be 0 because this is a permutation matrix, permutation array. So one of these numbers have to be 0. And what are we trying to optimize for in this one? Well, we're trying to optimize for in this one, the lexicographically smallest. And if we want the lexicographically smallest, that means that in every solution that we have, 0 has to be in one of these things somewhere. So we can always move it to the front, and then we can force the 0 to be the front in that way. And that's the only change. So here, and you can watch the live portion as well. I just changed everything to I don't know how it. I mean, you could change it in other ways, but you could just write, I00, and that's it. And this will be fast enough unless I made a typo somewhere. And that's pretty much it. And because this is I is equal to 0, well, the start why is this fast enough? Well, the start that is no longer. I mean, obviously you can also remove it from the parameter now, but the start goes from 14 to 1, which makes O of n to O of 1. So then now instead of n cubed, I didn't write this out. Let me. Total time is going to be O of n cubed times 2 to the n, which is this thing, I think. Right? But now that this is an O of 1, total number of inputs changed to this. Each input still takes the same time, and now this is n squared times 2 to the n, which I don't know what it is, but it's fast enough, right? And that's pretty much it. Like I said, a very clever, very cool observation that I got. And I felt very, nice solving it. But I think the only taint is that, the only taint is that in C++, and I don't know if it's true in other languages as well, in C++ you can do it the slower way with some minor optimizations apparently. So, anyway, that's all I have for this one. Let me show you. I mean, the code is not that long, right? So let me show you the top of the code with the memorization, right? I set this up as a 3-dimensional thing. I was just lazy, to be honest. I probably could have used that as an array. And then, yeah, and this is like we just got rid of the for loop. That's pretty much it. And the path reconstruction, we just kind of move from cell to cell. And that's pretty much it. And this is linear, by the way, because every time you move a step, you increase this by 1. Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live during the contest now. In a dumb way. Okay. -1. Hopefully this is good. No silly mistake, please. Oops. Oh, 2 people already got it. I took too long on that one. I should have gotten that much quicker. I knew how to do it, but just silly mistakes. Okay, 2 people got it, so maybe it's doable. Let's focus. Nums is a permutation. Okay. So score of what's that mean? Perms of 0. Nums of perm of 0. Perm 1, I mean. What does that mean? Focus. What does this mean? Nums of, is it given nums? So perm of 0. So this is what we're trying to figure out, I guess. And then here, and we're going to try the minimum possible score. So nums of perm 1. I don't know what this means. Oh, 14. Huh. 14 makes a difference. I missed that part actually. So then now we can figure it out, right? Yeah, okay. This is stupid, actually. Maybe, I don't know. Maybe I'm wrong. We want to get the permutation, not just the best. That's fine. We can path reconstruct. Okay, yeah, we can path reconstruct. We want the minimum score. I mean, it's annoying, but it's doable. We'll get it. We're not. We might not get it quickly, but we'll get it. Okay, so go. If R is less than best. focus on this for now. I hope that's good enough. What's 2 to the 14 anyway? Calculating. Oops, 2 to the 14 is 16,000. Okay, so 200 times 14. Okay, that should be okay. Yeah. Okay, so then now without it, we would say. Without it, we would say. Okay, so this perm 0 is this. Then what's perm 1? So we have to brute force perm 1. So this is actually the last one, it's not the first one, but we have to do the 0, right? How do I do this again? Okay, so I have to do the score here. Maybe this isn't so easy, because it's 14 cube and that just adds up, right? I mean, 3 people got it, so it's not impossible. 14 times 2 to the 14. It's kind of close though. I mean, maybe about last, but then the start. That's too much. 14 cube. I have to do an optimization. I do need a start. Am I doing okay? Q3 killed me. I should have done that one quicker, but could get this one quicker and that would solve it. But I thought it would be straightforward, but maybe not. I need to make one optimization. Nums of perm 1. Nums of perm 1. So nums of perm 1 is going to be the next digit. Focus. Am I being dumb? People are getting it, so I think I am. But do I add a score here? Oh, this is forced. Is it? Perm of n minus 1. So this is the last number minus this number. There's the difference, right? It's not just minus, otherwise maybe we'll take it out or something. These hours do nothing. Whatever. And everyone is just doing it this way, I think. But because this thing is the big issue, the base case. Yeah, I can't really think. Okay. No, it's 14. This is hard, but not apparently hard enough for people to not to get. What am I missing? If what I'm missing is C++, then I'm gonna be sad. But 14 times 14 times, it's like 44 million. Is that fast enough in Java? And then you have to path reconstruct, right? I don't know, do people get 5 wrong answers? What does that even mean? People are getting it though. I don't know how to do it without another factor. How do I take out that? Can I take out absolute value? Is there a way? Can I brute force the last digit? Does that even help? If I brute force this, No, I don't think so. Because it's just the same problem. You were getting it though, so I'm not doing well in this one. Let's just write it dumbly. Alright. Maybe it'll give me some ideas. Where's it go? That's the only thing that I need it for. Okay. Yeah, okay. Let's just do this and then we'll see. I don't know. I don't have any ideas right now. I know that I will have to rewrite this at some point for path reconstruction, but still. Yeah, I mean, I knew that it would work. But I mean, this feels very slow. Can I take advantage of some of this? I mean, is there some way to make this look faster? I don't know, 2 seconds for one thing. I feel like there's no. That's why I hate this. Is like I have to guess whether this will time out in a real case. But oh well. Okay. No one cares, Larry. I think that works. Like give me an hour. Takes 2 seconds, but and that is the next index. I should print this out or just even return it. Oh, that's a little bit wrong. Oh, current mask as well. Okay, I mean, not hard, but it's just possibly might take forever and timeout. I am going to ask ChatGPT to convert this to Java. Just because, yeah, I don't know. This does not need to be that big, to be honest. Is this how Java works? Yeah, I didn't think so. And can you implement cache? Maybe Java is not the way to go. It's making me do like this weird thing. Also, I just feel like that's not how you declare things in general. Name it ChatGPT. All right. Let's see if C++ is better, but all right, let's make this. Does it have caching? It does, but it uses string caching, which maybe is a little bit dubious. I don't know what I feel about this though. Is it going to time out? This takes even longer than my Python code because of all this conversion thing. I don't know. Should I submit it? You're doing it. I mean, a lot of people. All right, let's just. Let's try again, but without the crazy string things. Well, that's not good. One of these is 2 to the n. Line 63. Well, that's not good. I don't even know if this is right. But next is... Oh, I'm debugging this thing instead of actually thinking, which is actually also sad. Not that I know how to do it. Seems that this has in code. Just to make sure. So there's never been, so I'm just like going to a state that doesn't exist, which is the real issue. Am I doing something funky here? And so 1-2 is it, right? Why am I? Oh, because, okay. I'm dumb. Well, at least it worked in Python. But in here, it's a little bit silly. Alright, is that even right, at least? It's right. I don't know if it's fast enough. YOLO. If it times out, yeah. I mean, it's so hard to tell because this one's in like, you know, not too slow, which is very sad. How many people got in this now? 44 people. Okay, how do I optimize this? All right, spent too much time on this. Can I? I'm like missing one thing. Maybe more. Okay, so there's this thing. Can I take out the start and then do 2 DPs? Maybe. Like, what if I do this? So then now this is positive. Go ahead, maybe P go. I guess that's it, actually. That's a very clever way. Right, so then now, what does this mean? Is that even reasonable? So then now, that means that it's going to be this subtracting. if this works, to be honest. So I guess we'll see. And then now this is going to be I. No, this is I plus. Okay. And then now we don't need the current start anymore. Right. The previous we have to redo. Okay, done. Because that was actually not that bad to redo. Well, I think this has to be redone. Okay, right. Just run it real quick. I know that it wasn't going to work, but I was looking for some stuff. Go. Negative go. Because I didn't need to call it Pico. It's really confusing. But at least it prevents it from. Okay. But then now we have to do something like if best type is equal to 0. Yeah, okay. Is that at least right for the answers? Nope. Tell me why. So it, best start is best is weird. Okay, I mean best is definitely weird because of the negative. I think I could just do it this way. So the last is going to be this always returns the least. So it returns a negative thing, but if last is too big, then what happens? How do we do that? Trying to take out the absolute value, but this way is definitely not working. I don't know how to remove this. I was hoping this would. I was just very. Was hoping for some luck, to be honest. I wasn't confident about this. So it just looks very awkward. It should be like num sub star minus this, right? How did I factor that in? Without. Can I get rid of this for loop? Probably not. not the way that this is done. I built that very fast. Still don't know how to do it. Do I need to try every possibility? Is that a thing that I have to consider? I don't know how to reconcile this. I'm just playing around with it. I don't think this makes sense. Okay, how do I... Problem is... I mean, this is so fast. It's just that it's hard to tell how many inputs there are. Is it any slower? Is there any distribution of stuff that makes it hard? I have 40 minutes. I don't have any idea, to be frank. And this is just very long now because I don't have the next start thing. How do I get rid of it? I have no idea. This part that I can't figure out how to do. think this is wrong anyway. It's num sub I. Did that fix thing? That'll be funny with it. I just kind of messed it up. No, it doesn't change it. No, it doesn't change anything. Because that should not be 0 in any case. No idea. A lot of smart people though. I can't tell if I'm just missing an optimization. I mean, painfully obvious. I don't think if we ignore the last one. That changes a lot of things. I don't think you can just skip it. What am I saying? And that's the end to the 14 is just like some fun thing. Would be funny though. I would laugh. I mean, I don't know how to go around it. I guess I should want the C++ version. It is faster. Is that true? Why? Why is that? Maybe just luck. Well, we know that reverse is it's not true, right? So it's not like if that's the answer for all of them, that would be funny. But Can I bound this? How do I bound this? No, how would I bound this? Does that even matter? Are there impossible states that we don't care about? No, because you could always just. Well, you have to look at all the other ones without the incoming thing to find. Yeah, I don't know. Half an hour left. I still have no idea. But so then, what results are even, which makes sense. So can I break that apart? Does that give me anything? Knowing that the results are even. They're even because if one thing is one away, why is this 12? I did have a pattern in my head until I saw this is 12. I don't know how to, but if there was a pattern, then I don't know, this wouldn't have been any 0 to 4. I still don't know if this is a math problem or programming problem. How do I dissect this? I feel like I'm missing something here. I don't know if I'm doing anything useful. Why is this 6? Because of 3 minus 0, maybe? Well, 3 minus 0, and then 0 minus 1, 1 minus 2, I think. If I could early terminate, maybe that would help, but I don't know. Yeah, maybe I don't know this one. We can just eliminate one of these, but I can't. Try to figure out a tie-breaking strategy. But it's not symmetric, which is actually a little bit surprising. Is 0 always the first element? Is that it? That's what I've been noticing, right? If that's it, I'm not gonna be happy. That would be hilarious. Am I still in C++? No. Where's my I? YOLO. Well, I mean, that is actually pretty nice. Not gonna lie, that was a nice one. Like it fooled me for so long, and it is a disaster. Because the rest of the problem is easy, but I don't know how to prove that. That's. Let me clean this up and then we submit. No, I mean that's fine. It's fine. Let me clean up a little bit. Why is num sub 0? Oh, because you might 0 at the end, but why does that matter? Oh, because lexicographically. I guess lexicographically it makes no, because by symmetry we can vote, because the answer is going to be a rotation of this, and so if the answer is a vote, that is so okay. I mean, yeah, I mean, I had most of it written. Like, I guess that's how Pure got in 10 minutes. It took me a while, because, okay, wow, that is a very good observation. I mean, I only noticed it by pattern, but that is, because if one, oh, wow. I guess we don't. Just cleaning it up a little bit. That is okay. I mean, I accept defeat. It was. I feel like that's actually a very cool problem. I mean, I would be much happier, obviously, if I got it right. But yeah. Oh, that is a very nice observation, actually. That's so far behind now. It is what it is. Anyway. Oh, let me look for shoutouts. I think, well, I mean, this is like a little bit behind as well. But yeah, I'll get some shout. Oh, shout out to Joseph. Congrats. Anyone else for my? I guess that's it. Unless if you know it, if you are in my Discord, give a comment, and if I notice your thing, I'll give you a shout out. But yeah, that is a good one. I if I didn't print it out, I would have never noticed it. But it took me a while. I was trying to figure out why because that's the thing that I was doing with this, because that it was in theory reverse it, but then I noticed that it didn't reverse the first number, which I guess is probably because That took forever. Wow. I mean, I knew how to do the core idea immediately, but wow. Because I was, and this is actually a bug in how I was doing it. Nope. Oh, because this is not the one with the for loop. That's why. Okay, that's fine. Because the reason is because actually, if I had kept this and instead I did this, and I actually messed this up because I changed it here and not here, then I would have noticed that all the answers would be a little different. But because of my bug, I noticed that, okay, maybe I messed something up here along the way. Oops. But yeah, because of my bug, all my stuff still started with 0. And it didn't really connect it to me for a while, but yeah. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.